Imagine this for a second. You're sitting in one of those cold, fluorescent lit exam rooms.
Yeah.
And you've got this piece of paper in your hand, pathology report. You've just been told you have cancer.
It's a terrifying moment.
Right, but it's not just scary. It's like it's written in another language. You're seeing these words like colorectal, adenocarcinoma, wild-type KRSS, BRAF mutations.
It's just alien code. And you look at the person in the white coat, your doctor, and you expect them to have the translation. You need them to.
But here's the reality we're unpacking today, and it's a tough one. The person in the white coat might be just as overwhelmed as you are.
That's the core of it.
We are doing a deep dive into a paper from Cancer Cell, just published in early 2026. It's by Justin G. and Travis Zach, and the title, well, it sounds like a thriller. AI for cancer treatment information. Can academia stay in the game?
And it sounds like it's about a tech battle, but what it's really about is something called the chain of trust in medicine.
The chain of trust.
And what happens when that chain starts to, rust?
Yeah. Okay, before we get to the AI, the robots, let's just set the stakes. Why is my doctor overwhelmed? I mean, they went to school for, what, a decade?
It's the sheer velocity of information. In 1950, medical knowledge would double every 50 years.
Okay.
Today, it doubles every 73 days.
73 days? That's insane.
It is. There are thousands of new papers, new biomarkers, new genomic variants. No human can track all of that.
So relying on human memory, it's not an option anymore.
Not at all. And that brings us right back to that concept you mentioned.
The chain of trust.
The chain of trust. This is really the mental model for our whole deep dive today.
So let's break it down. What does this chain look like?
Okay, picture a bucket brigade, like at an old fire. At the very top, you have basic sciences, the lab experiments.
Right.
They hand their data down to clinical trials. Those results go to guideline bodies, like the NCCN in the U.S.
Rule book writers.
Exactly. They write the rule books. And finally, those rule books get handed to your doctor, who then has to interpret them for you, the patient.
But if the data is coming out of a fire hose, the doctor at the end of the line is they're getting soaked, but they're not catching any of it.
That's the perfect image. The chain is breaking right at that doctor link. They just physically can't keep up. So the industry comes in with a patch.
Artificial intelligence.
Right. But we're not talking about the kind of AI from, say, 2023. I remember when ChatGPT first came out, people were asking it medical questions, and it would just make things up.
It hallucinated. I mean, the source we're looking at even references a study where those early LLMs recommended the wrong cancer treatment 34% of the time.
A 1 in 3 chance of being given bad advice.
Dangerous advice, yeah. Not great odds.
Oh.
So to fix this, a new system was developed, an architecture called RAG, and we really need to unpack this term.
RG, retrieval-augmented generation. I've heard it described as, the difference between an improv comic and a research librarian. That is the perfect analogy. Let's just visualize that.
Right.
A standard LLM, like the old GPT-4, it's the improv comic. You shout a prompt, and it just starts talking. It's riffing, guessing the next word based on probability and, vibes.
It sounds super confident, but it could be totally making it up.
Exactly. Now, RAG. RAG is different. It puts a step in the middle. You ask a medical question, and the RAG system first acts like that librarian. It freezes.
Yeah.
It goes and searches a trusted database, a specific set of medical journals, for example. It pulls out the relevant pages, and then, only then, does it show those pages to the AI and say, answer the question, but use only this text.
So it's an open book test.
It's an open book test.
And you're not allowed to use your imagination. You have to quote the source.
You got it. And that grounding is what's supposed to stop the hallucinations.
Okay, let's do a quick pause here, recap, before we get into the drama of the study.
Good idea.
1, medical knowledge is just exploding. It's too fast for any human doctor to keep up with. 2, this is putting a huge strain on the chain of trust that goes from the scientist all the way down to the patient. And 3, to fix this, we've moved from improv AI, which just makes stuff up, to librarian AI, which is called RAG, that looks up the facts before it speaks.
Perfect. Okay, now let's introduce the conflict.
So our source paper introduces us to a team of academic researchers, a group led by June, and they built a RAG tool just for oncology. They connected it to a database called Molmanac. What's that?
Molmanac is the Molecular Oncology Almanac. Think of it as this pristine, really carefully curated database. It's built by academics for academics, and it maps all those alien genetic terms to specific drugs.
So they've got this high-quality, expert-built database. They hook up their AI to it, and then they give it a test.
Yep. a test, 102 real-world questions about things like FDA approvals and cancer biomarkers.
And how to do.
Over 90% accuracy.
Which sounds amazing, like a total slam dunk. Academia saves the day, right?
It really seemed that way.
Yeah.
But then the authors of our source paper, G and Zach, they decided to play the villain. They stress tested it.
Stress tested it against what?
Against the big commercial giants. Specifically, a tool called Open Evidence and the RG-enabled version of ChatGPT.
And we should be clear, the commercial tools are the ones backed by, billions of dollars. They're not just looking at one almanac. They're indexing millions and millions of paper.
Right. And this is where the story completely pivots, because they found a specific case where that 90% accurate academic tool failed. And it failed in a way that is, well, it's both biologically fascinating and frankly terrifying.
Okay, let's walk through this. This is the panitumumab case.
Right. So visualize a patient. They have colon cancer, colon adenocarcinoma. But there's this one tiny detail, a real needle in a haystack. The tumor is in the ascending colon.
The ascending colon. That's on the right side of the body, isn't it?
Yeah, correct. And you might think, well, a colon is a colon, but it's not. Biologically, the right side and the left side are totally different. They develop from different embryonic tissue. They have different blood supply.
And they respond differently to drugs.
That's the critical part. They respond very differently to drugs.
So right-sided colon cancer is a different beast entirely.
It is. And the drug in question here is panitumumab. It's a very powerful drug for colorectal cancer, but, and this is a huge, but clinical trials have proven it does not work for right-sided tumors.
It doesn't work at all.
It doesn't work, and in fact, it's just toxic. You're giving the patient all the side effects, severe skin rashes, lung toxicity, for zero chance of any benefit.
So it's poison, essentially, for that specific patient.
Exactly. It's a strict do not prescribe situation.
So G and Zach, they feed this exact patient profile into the academic almanac tool, the one that scored 90%. What does the librarian say?
It failed. The academic tool saw colon cancer, it saw the right genetic markers, and it recommended panitumumab. It completely missed the ascending colon nuance.
That's a massive error. That's a patient safety incident just waiting to happen.
It is.
So what about the commercial giants? Open Evidence and ChatGPT.
They got it right. Open Evidence flagged the location immediately and said no. And even ChatGPT got it right in 3 out of 4 attempts.
Okay, this totally flips the script. You always think of academic as being more rigorous and commercial as being, maybe a little sloppy. But here, the big commercial tool protected the patient, and the specialized academic tool put them in danger. Why?
And this brings us to what I think is the most important concept in the whole paper. They call it verification friction.
Verification friction. I love that. What is it?
Well, when the academic tool gave that wrong answer, it was a black box. It just said, prescribe panitumumab. It didn't give a link. It didn't show the guideline. It didn't explain why.
So a doctor sees that recommendation, and to double check it, they have to.
Yeah.
Leave the tool, open up a new browser tab, go search medical journals, and read 5 papers.
Yes. That is friction. And in a busy clinic, friction is fatal to the truth.
Yeah.
Doctors are rushed. If verifying an answer takes 20 minutes, they might just trust the tool.
And the commercial tool, how is it different?
The commercial tools are obsessed with user interface. So when Open Evidence said no, it didn't just stop there. It probably showed a little snippet from the NCCN guideline. It gave a direct link to the clinical trial.
Yeah.
It showed its work.
It's the difference between a friend telling you a rumor and a lawyer handing you a file with all the evidence.
That's it, exactly.
Yeah.
And the source argues that showing your work, giving those citations, is maybe the single most important feature. It lets the doctor verify the claim in seconds, not hours.
Okay, let's do another quick recap of this part. So we have this face-off, right? Academic tool versus commercial tool. The test case was right-sided colon cancer, and this drug, panitumumab, the result, the academic tool got it wrong, recommended a toxic drug. The commercial tools caught the error. And the big lesson was that it's not just about having the right data, it's about verification friction. The tool that makes it easy to check the facts is the safer tool.
That's the perfect summary. And this leads to the bigger picture argument, which is that academia is losing the interface war.
Right. They have that diagram in the paper, Figure 1A. It lays out this whole ecosystem. You have the academic track on one side with scientists building these careful little databases like Almanac.
And on the other side, you have the industry track, these companies building massive engines that just ingest everything.
It's a resource war.
It is. The commercial companies are partnering with the guideline bodies. They're paying for access to journals. They have huge teams of engineers just polishing the user interface. An academic lab with, 3 grad students,
Yeah.
they just can't compete with that.
So if industry is winning, if their tools are more accurate in practice and easier to use, why don't we just hand them the keys? Why shouldn't a company like Google or OpenAI just run all of medical diagnosis?
Because of the trap. And this is where the paper pivots to the future, and honestly, it gets a little dark. We have to talk about something called agentic AI and data poisoning.
Agentic AI, that sounds like something out of a spy movie. What's an agent versus a chatbot?
Okay, so a chatbot is passive. You type, it types back.
Right.
An agent is active. It can use tools. It can actually write its own code, execute that code, browse the live internet, download software. It can even control physical robots.
So instead of asking it to summarize this paper, I could tell an agent, go read every paper on colon cancer from the last year, pull out all the survival data, run a statistical analysis on it, and then email me the graph.
Exactly. The source describes these virtual labs where AI agents are acting like junior scientists, planning experiments, running the numbers, even writing the manuscript drafts.
That sounds incredibly powerful. I mean, we could accelerate cancer research by a decade.
We could, or we could accelerate data poisoning. Because remember, that whole RAG system depends on retrieving documents from a trusted source.
Yeah.
But what happens if the source itself is corrupted?
Garbage in, garbage out. But it's worse, because the AI thinks the garbage is a gourmet meal.
And the source gives a very specific, real-world example of this happening. It involves the US CDC, the Centers for Disease Control.
Okay, this is a sensitive area, but let's stick to exactly what the paper reports. What happened?
So the authors note that in 2025, the CDC's own website had statements on it suggesting a possible link between vaccines and autism.
And just to be absolutely clear for everyone listening, that contradicts decades of overwhelming scientific consensus and peer-reviewed evidence.
Correct. The source paper explicitly says those claims were in direct conflict with published evidence. But here's the failure mechanism. An AI agent is programmed to see a .gov website as ground truth. It's a high-trust domain.
Oh, I see the trap. So the AI goes to the CDC website, it reads that text, and because it's a trusted source, it just absorbs that misinformation and starts repeating it.
It creates a feedback loop of falsehoods. The AI will confidently tell you there's a link, and it will even cite the CDC as its source. And just like that, the chain of trust is completely shattered.
And it's not just about, political interference. The source also brings up predatory journals.
Yes, this is a whole shadow industry of fake scientific journals that'll publish absolutely anything if you pay them. So if an AI agent is just scraping the web for new research, it might find a paper from one of these journals claiming that, drinking bleach cures cancer.
And unlike a person, the AI might not recognize the subtle clues that the journal is fake. It just sees a PDF that looks like scientific paper.
That's it. This is data poisoning. If the well is poisoned, the RA system just becomes a really efficient way to pump that poison to more people.
So we have a huge dilemma. Academia can't build the best, most user-friendly tools, but the industry tools, while powerful, are vulnerable to this kind of poisoning and ultimately are motivated by profit. What's the solution? What's the new role for academics in this world?
The source ends with a call to arms for academia. It basically says, stop trying to be the search engine. Start being the auditor.
The auditor. I like that.
Academia's job isn't to build a better ChatGPT. Their job is to build the stress tests. Their job is to create those 102 difficult questions, to be the ones who find the panitumumab error.
So they need to be the independent watchdog.
Yes. They need to verify the intelligence. When a commercial tool says do X, the academic community needs to be the one that runs a check in the background and says, wait a minute, did you check for the ascending colon contraindication?
It's a shift from creating the knowledge to policing the knowledge.
I think that's the only viable path forward. We're moving from a world of search into a world of answer engines. And in this new world, the most valuable thing isn't information anymore. It's verification.
Let's bring this home for everyone listening. Whether you're a doctor, a patient, or just someone who Googles their symptoms at 2 in the morning, what's the takeaway?
The takeaway is, show me the receipts.
If an AI gives you an answer without a citation, it's just gossip.
It's just gossip. If you're using an AI tool for any kind of health information, look for those little bracketed numbers, the little 1s and 2s. And don't just see that they're there. Click on one.
Be your own investigator.
Exactly. Does that link take you to the New England Journal of Medicine? Or does it take you to a broken link? Or a blog that's trying to sell you vitamins? The existence of a citation is not enough. The quality of the citation is everything.
We can't be passive anymore. The chain of trust is under so much strain that we all have to forge our own little links of verification.
That's the new reality. Convenience is the enemy of safety in this game.
I want to leave everyone with one final thought, building on this idea of agentic AI. Imagine it's 5 years from now, 2031.
Okay, I'm with you.
You're sick. You go to a clinic and it's run by an AI agent. It scans your genome, it analyzes your blood, and it prescribes a pill. It tells you, I am 99.99% certain this pill will save your life.
Sounds pretty good so far.
But when you ask why, when you ask to see the research paper it used or its line of reasoning, it says, I can't show you. The reasoning is too complex for a human to understand, and my data sources are proprietary trade secrets.
The ultimate black box.
So, do you take the pill? You have near perfect statistical certainty on one side, but you have zero transparency on the other.
That's the question of our time, isn't it, for me? If I can't verify the source, I don't swallow the pill.
I think I'm with you, but I have a scary feeling that a lot of people will take the 99% accuracy and just hope for the best.
It's a huge gamble, and as we saw with that CDC example, even trusted numbers can be based on poison data.
This was a heavy one, but really important. The era of the robot doctor is here. The rules are just still being written.
And until they are, stay curious, stay skeptical.
And always check your sources.
Always.
Thanks for joining us on The Deep Dive. We'll see you next time.